Hey there. So today we are going to solve another LeetCode problem named rotate image, medium level, and it goes like this. You are given an NXN 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input to the matrix directly. Do not allocate another 2D matrix and do the rotation. And there is a couple of examples here, but obviously we all know what the rotation means, so let's start to solve the issue. First of all, let's check the size of our matrix for some edge cases. I think that if the size of the matrix is less or equal to 1, then we don't need to do anything at all and could shut down the execution of our code right at this moment. As for the rest, let's check the requirement. We have to rotate the image in place. And to guarantee that, let's limit ourselves by creating a single buffer of integer size, which we are going to use for all the swap operations. All right, let's check for some simple test cases. The most simplest case, the 2x2 matrix. To rotate it, we just need to do 4 operations to swap its corners, like this. Looks pretty simple, and we can do it for any size of matrix, right? So let's check the more complicated case, the 3x3 matrix. Let's start the rotation by rotating its corners. And now we just need to rotate these elements on its sides, and the matrix is rotated. As you see, we've just finished the rotation of the matrix by rotating its outside layer of elements. And basically we can do it for a matrix of any size, right? We can first focus on its outside layer, then do something with the middle layers, and finish when we achieve the core. Sounds like a plan, right? So let's get back to our code. To iterate through the layers, first we need to find some max layer to deal with, and as you can suggest, it is related to the size of matrix. We are going to just divide it by 2, and also we don't need the core element for the odd size matrix, so we are going to just leave it behind. So for the layer from 0 to max layer, we need to find some anchors to work with. What do I mean by that? First, we need some minimum of column, the index of the columns to work with. So, and as you can understand, it's going to be equal to our layer. The same could be said about the min row. When we go through the layers from the outside to the inside, we're going to shift the min column and min row values like this. As for the max values, it's kind of the opposite. We're going to use the last index of the column and remove the index of the layer from it. The same could be said about the max row. And finally, we have something to work with. First, let's start with the corners. I would suggest to start from the bottom left one. So we are going to put the value from this corner, which is the max row min column, to the buffer. Now let's put the value of the bottom right corner to the bottom left. Now let's do the second swap, which is putting the top right value corner to bottom right corner. Then we're going to do the same swap for the top right corner, and we're going to put the top left value there. Finally, we are going to put the value from the buffer to the top left corner. Sounds good? But we still need also to do this for all the values on a side, right? Let's now iterate through the indexes of all the elements on a side of our particular layer. For example, iterate through the columns. So we're going to start with the min one and finish with the max column -1. We are going to reuse all our logic here, but it does need some modifications. First of all, let's check for some kind of shift or offset, whatever you name it. Basically, it is the difference between the column and min column. And now let's use this value to modify our logic. So let's check the bottom left corner first. With each operation, we will start first here and then we'd go up, 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 which means that we would need to modify the row value of this index at each step. With the bottom right corner, we would actually go to the left, which means that we would need to decrease the column index with each step. With the top right corner, we would go down with each iterations, which means we would need to increase the row value, row index with each iteration. And finally, with the top left corner, we are going to go right, which means that we are going to modify the column and increase it with each step. Okay, let's check if our solution works. Yeah, amazing. Let's submit it. Cool. As you see, the execution runtime stays on the edge of threshold, and because of that, it is kinda 0 milliseconds, and it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, put your request to the comments, and see you next time. Cheers!